All right, so Docker. Um, so Docker is, you can think of it as like an amped up virtual environment. So why do we have virtual environment? So when you create a new Django project, why would you create a virtual environment there?
So you can run on any machine without any pre-installed stuff that you didn't know about.
Yeah, so I think that would apply to Docker, but what about a virtual environment? So if I'm on my machine and I want to create a new Docker project, why might I create a virtual environment first?
So you don't have to install like a ton of dependencies and on your computer, and then when you're working on another project, you have to install a ton more, and they might conflict with each other.
Yeah, it's basically the general point is to manage dependencies and reduce conflict. So for example, if I have, Docker 2 point whatever 2.2 on my local machine, um, and I want to create a new Docker project that requires Docker 4.1, then I have it potentially an issue. And if that's just one layer of conflict, potential conflict or complexity. One, there's potential for human error because, well, I have a version of Django that works, so I should be able to run it, but it's not actually the version that you need. How do you make sure you're running the correct version of Django? If I do Django admin, how do I know which version of Django is my system going to pick? And then you start this problem just multiplies because you have lots and lots of additional dependencies. So Django needs other things. Those other things need other things. You install third-party packages, and then those third-party packages need other things, and they need, the versions of other packages they need are specific or greater than whatever. And so it just becomes a mess if you have lots of different projects on the same computer trying to manage all that complexity. So you create a virtual environment to basically to isolate your dependencies. And one benefit of that is you can tell other people exactly what they need, and then they can pull down. This is yeah. So they can if they have everything else that they need, you can create a virtual environment on their own computer, install just the dependencies in the virtual environment, and expect it to work. The there's some more issues with that. So one is if you're on a Windows machine and someone else is on a Linux machine and someone else is on a Mac, that virtual environment may or may not be enough. And if you have a whole program and you're packaging it up and you want to run it on lots of different servers, then you have that same kind of issue where it's possible that I want to run my Django project, my Django application on a server. It requires a certain version of Postgres to be available, and then I try to run it on another server, and so there's a conflict there. And maybe I don't have access to the other server. I can't reinstall things, or if I install something else, it conflicts with something else, blah, blah, blah. So things can get very messy and complicated. And the ideal is to just, you want to keep everything as clean and isolated as possible. So you can basically pretend like your application is just a standalone package. So what Docker does is it not only provides what would be like a virtual environment, but it's like the entire operating system. It's like having another computer inside your computer. Instead of just having another pip environment in your computer, you have an entire operating system. So you can take those principles and you know apply them at a higher level. So that kind of maybe sounds abstract, but what I'd like to do first off, in order to do this, if you're on a Mac, you're gonna have to have Docker Desktop. You can just install, it's pretty easy. And if you're on a Mac, there's also Docker Desktop or Windows Docker Desktop. And I think at this point, there are really no issues, so you should just be able to install it and run it. And if you're on a Linux machine, then you can just install Docker directly and use it. Okay, so assuming that you have Docker Desktop installed and running, you should be able to just execute this Docker command. And by default, it's going to tell you, this is the usual man page or manual page, which is going to tell you all the options you have. So there's image, network, node. So most of the stuff we're not going to worry about. We're just going to focus on for today. We're just going to focus and really, there's only a few things you need to really worry about. We're going to focus on images. So if I want to see all of the images that I have on my computer right now, Docker images, I have some stuff which I should really clean up. Most of this is junk. So I have all of these images. And the question is, well, what is an image? And an image is basically like a class. So in object-oriented programming, you have a class, and the class itself typically doesn't really do anything. It's more there as a template, and then you create an instance of the class when you actually want to do something. And Docker has a similar kind of structure there, where you have an image, which is basically like a model or a description of the system, and then when you actually run it, it creates a container. So a container would be like an instance of the image. So you have a bunch of images, and you can create your own images. You can use other people's images. So you can go to Docker Hub. So Docker Hub is kind of like GitHub. Let's do. So GitHub is for storing your code, right? You write code, you have an application, you want to save it and package it up and then push it up to GitHub so that you or other people can have access to it. And Docker Hub is the same thing. So you create an image, you package it up, and then you push it to Docker Hub so that you or other people can access it. So you can pull and push images just like you create an application, put it in a virtual environment, and then push it up to GitHub, and then you can pull it down and run it. You can do the same thing with an image. So Docker Hub, there are other Docker registries. AWS has one. There's a bunch of other ones. And if you create an account, then you can have your own, just like you have a GitHub account, you have your own account, and you can push and pull the images from your account. And you can also push and pull any public images, just like on GitHub. If someone has a public repo, you can just go there and pull down their code. Okay. So there are a few kinds of images. They all are basically going to have to start with an operating system. So you have an operating system, and then sometimes people will add on specific things. So there's node. So there are official containers and unofficial containers. So here is an official node container. So the people in charge of node maintain this. So it's reliable and blah blah blah. There's also just random people. So I don't know what this is, but so this guy has node image analyzer. So anyway, so there's a whole bunch of images. So if you search for something that you want, so I want to run a node application, or I want to create an application that has node in it, you would do a search for node, and you can click here and you can see what they have. So Node.js is a JavaScript platform for server-side and networking applications, blah, blah, blah. And then they have here, so just like if this were a pip repository, you would have, pip install whatever the package name is. Here we have docker pull node. Or maybe the equivalent would be GitHub. So you clone something down or pull it down. So the base image is node, but all of these images can potentially have lots of different versions. So here are all the different potential versions. You can think of this as like, if you have Django 3.4 and then Django 4.1, it's all Django, but there are different versions. So this is kind of a similar thing. And this is pretty overwhelming at first when you look at it. There are a few things that you'll notice with almost every image is that almost all of them will start with Alpine. So Alpine is a very small, minimal Unix operating system. And so one of the things you want with an image is for it to be as small and lightweight as possible. So if you just need to have some kind of system that has Node running it, maybe you don't need to install like Ubuntu or some more full-fledged, full-featured operating system. You just need something very bare bones. And so Alpine is very slim, so you're almost always going to see, and almost everything has some kind of Alpine build. And the way that these work, like this official node image, all of these start from another image. So this node image is basically going to say, okay, install, this operating system, Alpine version 3.16, and then do some other stuff and install node, and then that is packaged up and given to you. So you could recreate what the node image is, but why bother if they have it for you? So I'll just click on one of these kind of at random, and this takes me to the actual what's called a Docker file. So you can create your own Docker files, and you will. So you can create a Docker file, and a Docker file is where you define your image. And there are a few. So this is fairly complex. Docker files can be very simple. Usually they're very simple. Sometimes they're more complex. But the basic properties you're going to have are from. So every Docker file is going to start with from. And from is what is the base image that you want to start from. So this node image is going to start from Alpine 3.16. So Alpine is an operating system. So it's going to start from here. So install the operating system. Then once you have the operating system installed, do all this other stuff. Create this environment variable, env. And then run is going to be like, pip install whatever, install this, update this, blah, blah, blah. So this is just going to be bash script, usually installing stuff. And then sometimes you'll copy stuff. So if you have local files, so if I want to create a Django application, I'm going to start with some image that has Python on it because I need Python to run Django. And then I might want to install some other things, install all of my dependencies, install Django, install requests, install whatever other libraries I'm using. And then once that is installed, then copy over all of my code into the image so that it can run there. So that's what copy does. And then you have entry point. You also have command. I wouldn't worry about entry point right now. Command cmd. So this is the command that you want to run when you create an instance of your image. And we'll show examples of all this stuff in a second. But so if I want to use the node image, that's what's happening here. So that's what they're doing. But if you want to actually use the node image to start and make your own image, then you would start with from node 19, blah, blah, blah. So images can be based on other images. Okay. So some of that is probably going to be fairly abstract, but I'm going to go to the Alpine. So Alpine has an official image here, and they have a number of different versions. So what I'm going to do now is I'm going to pull down this image. First off, I think I have it locally, so I'm going to delete it. So Docker RMI, you don't need to know this right now, but Docker RMI, this is remove image. So just like, on your file system, you have RM or whatever, this is the remove image. And then I can paste in either the name, or I can also paste in this this hash, which is the ID. So either one of these should work. And it's deleted now. And if I do Docker images, it's gone. So my I don't have Alpine installed right now. So if I want to get the Alpine image on my computer, I can run this. So if I just run Docker pull Alpine, then it's gonna implicitly use the latest tag. So if I do Docker pull Alpine, I can run this command, and that is the equivalent of Docker pull Alpine : latest. So this, you have the base image name right here, and then colon, and then this part is called a tag. So this is like the more specific version that you want. So if I wanted to run this in particular, like 3.14.8 for whatever reason, I would just do that. And that'll give you the specific image. So I'm just going to run it like this, and it's going to implicitly grab me the latest. So when I run this, notice it says using default tag latest, and then it's going to pull from stuff. And so Docker tries to cache as much stuff as possible. So I already pulled this this image down on my machine, and images come in what are called layers. Well, I'm not going to go into that right now. But so when you pull an image down on your machine, it's going to it's going to check if you already have that particular layer saved. So it's just going to save you and Docker some time and effort. So just so you know, if the first time you do this, your output's not going to look exactly like this. But okay, so we have an image of Docker. So I'm going to do Docker images, and let's see if the Alpine. So Alpine now exists here. Okay. So I have this image. I went to Docker Hub. I found an image that I thought would be useful, and now I have it installed on my local computer. But this is like a class, right? It just kind of sits there. You need it, but it doesn't do anything in itself. So what I want to do now is to run this operating system. I want to run this other computer on my computer. And the way you do that is with the run command. So Docker run. And then you pass it the image name. So I can pass it this name. I could also pass it the image ID here. And you can also, if you have multiple Alpine containers, you might have to specify. If I have Alpine, 3.10 and Alpine 4. Whatever, then you're gonna have to specify the version. But I just have one Alpine container, so that will be fine. And if I run this, the container is going to run, and it looks like it didn't really do anything, and it kind of didn't really do anything. So let's take a look at the documentation. So how to use this image. So this is telling you how to create your own Docker file. Notice from. So the first line in any Docker file is going to be from blah, blah, blah. This is the Alpine version, and then run. This is APK would be like Homebrew. This is the equivalent. This is just the package manager. So if you want to install stuff, you use APK, and then MySQL client. This is just an example, and then the entry point, blah blah blah. So by default, I'll just go ahead and look at the image here. So when you run this, let's see if I can find the, maybe they don't have a GitHub repo. Yeah, another thing, just you don't really need to worry about it now, but if you actually want to start pushing up and sharing your images, you're gonna have to be careful about how you build it. Because if you're on I had this problem at work. Actually, I built an image. My work computer is an M1, and I pushed it up to run on a server, and the server was a Linux machine with a different architecture, so it didn't work. But when you build it, you can define that. Anyway, I just that's just the heads up. Okay. In any event, this image will run, but it's not really doing anything useful. It's just gonna like, sometimes certain images are predefined to do specific things, but this is just a general operating system image, so it's not really going to do anything interesting when you run it. So you're going to have to modify the command. So just like when you create an instance of a class, sometimes you can create an instance and you could just have all the init parameters just be default and not do anything interesting. You could also pass in specific parameters and then you customize it, basically. So we want to have a custom instance of this Alpine container. So you can pass it some additional commands. So a very common one that you'll do is you'll want to run basically a bash terminal inside of the container. So to do that, you go docker run. So that part is the same. And then you have to pass it some flags. So one flag is, so -it, these are two different flags. This basically makes the terminal interactive. So you can, it'll basically, you can use your shell as the computer shell. So just like if you SSH into another computer somewhere, your shell kind of becomes the shell of the computer that you're using. So it's the same there. So docker run it, and then the container or the image Alpine, and then the command you want to run. So Alpine doesn't have bash, but it does have sh. So you can run this. And now I am inside of my container. So I can do ls, and I can see all this stuff. So I'm actually I'm attached. I'm basically attached, and I'm running the shell here. So I can do echo hi, whatever. So I am inside here, and if I wanted to install something, I could install it just like anything else. But this is a fresh operating system, and the nice thing, I can do whatever I want with it. I can run it, I can blah blah blah, and then I can just destroy it. So it's just like a virtual environment. They're easy to create and destroy. So I'm going to exit from this. Okay. Any questions so far?
Yes, I have one question.
Sure.
So from here, would we be able to install other things within the Alpine Docker image to set up
Exactly.
like a environment or something?
Yep, exactly. So so now I'm back inside of this container. Actually, let me exit real quick just to show you. So I'll do docker ps. Let me close that. So I have another container. So docker ps will show you the currently running containers that you have. So I had this from earlier. This is a container based on Postgres image. So I'm going to stop. So Docker stop. This is like, shut down this running container. I pass in the ID. You can also pass in just like a few, as long as it's enough to uniquely identify it, you can pass in a partial ID. So that should be stop. And if I do Docker PS again, then there's nothing there. So I don't have any containers running right now. There's another flag you can use, Docker PS-A, and this will show you all of the containers that you have, whether or not they're stopped. So this includes stopped containers. So I should clean some of this stuff up, but so I have these containers, and containers will get a default name. So you can specify when you run a container, you can give it a name, or if you don't, it'll get a default name. Okay. So back to your question. Let's go run the container. Oh yeah. Okay, so I'm going to run this container, and then I'm going to go into another shell. I'm going to create a new tab, and then I'll do Docker PS. You can see that I can see that my Alpine container is actually running. So I can't access it directly from here, but what's going on there? Yeah, so I have the Alpine container running, but here my terminal is taken up with the actual process, so I can't see that. Okay, so I have this running. So if I want to install stuff, here's actually an example. So I'm gonna just run this command because it happens to be right here. So I want to add MySQL client for whatever reason. So there you go. And now I'm installing this not on my local machine, but in the container. So MySQL. I don't know if that will work. So I don't know how to actually use this, but you can see that it was installed. Does that answer your question?
Yes, sir. Thank you.
Okay, so you can definitely just create, pull down like a generic operating system, and then go in just like we did on InstallFest and just install everything you need. But probably what you want to do is to actually create a Docker file, which we saw, which will define your own image, which will install everything you need, and that way you can just use the image directly. You don't have to go through and manually do this thing every time you create it. Okay, so now I'll go here and let's see. I'll kind of follow. If you guys want to look at this README later, you can walk through it. I'll just take a small example here. So let's run two different Python containers right here. So I want to do first. I'm going to look at my images and maybe clean some up. Docker PS-A. So Docker RM. So to remove an image, you do RMI. To just remove an instance of the image or a container, you just do RM. And then I can paste in this ID, and you can do multiple at the same time, and something like that. And then Docker PS-A. So I have fewer images now. I can still delete this one. I think that'll probably be good enough for now. Docker RM and then the ID. All right. So now I'm going to go back to Docker Hub, and you can just do obviously just general internet searches for this stuff. You don't have to search on Docker Hub, but Python. All right. So I'm not sure if they have, now that I think about this, so Python 2 is deprecated. So they might not have it listed here, but I'm just gonna try and install Docker pull Python, and then I'll just do 2. And I'm gonna hope that there's an image that fits that description. We'll see. Okay, good. So looks like it does exist. So I'm gonna do Docker images. And I have Python. This is a 3 version of Python. I have another Python somewhere. So here's the one that I just installed. So Python 2 is deprecated now. So this is an old image, but I should be able to run it. So if I run the Python image, Python or Docker, run Python, and then I'll make sure I give it the tag because I have multiple Python images here. So it just, again, this image doesn't really do anything interesting by default. It's just supposed to be a base for you to build on to make something else. So we're gonna need to run it with something more specific. So 90% of the time, that's gonna be bash or shell. So let's see if they have bash. So the IT flag makes it interactive terminal, and then I basically will execute the shell. So now I'm inside of my Python 2 container. So I can just do my usual stuff. And if I want to see what version of Python I have running, Python -- version. And I'm running Python 2.7.18. So I can actually go into the Python shell here on my container, the Python. And now I'm inside the Python shell inside my container. So I can do things like print. And this works. So notice that the syntax is different in Python 2. So if I try to do print, hi, like Python 3 syntax, it surprisingly allows that. Interesting. So that probably shouldn't let, maybe 2.7.18. Yeah, that's a good question. I should find something that breaks. I believe that this example works. So let me see what version, what image I install.
I don't think, does f strings not work in Python too?
F-string should not work. Yeah. So let's do x equals. Let me create a variable. X equals hi. Y equals f x. Yeah. So yeah, I am in fact running an older version of Python. It's possible that the minor version 18 uses different syntax here. So in any event, so this would work. So I can actually exit this container, or exit the Python shell, and then exit the container. And I can grab a different Python image. So Docker images. I have one on my machine, so I'll just grab one of these Python. I'll grab this one. So 3.9.15. So Python run -it. I'll pass in that, and then bash.
It's Docker run, not Python run.
Oh, thank you. Thank you. Jeez. Okay. So now I'm inside. If I do Python -- version 3.9.15, so I'm going to go into the shell, the Python shell here in my container, and I should be able to do let's see if I can just copy the same thing. And that works fine. So, you know, you can have totally separate environments. You're not just limited to things like, you know, Python and Node. You can install any, you know, anything. So I'm gonna exit from the container, and I'm gonna do Docker PS dash. I'll just do PS. Nothing is currently running. Docker PS. So by default, if you are on the shell of another container and you exit, it will stop running the image. So now I have these containers. Every time I run it, it's creating a new instance, right? So that's why I have, even though these are based on, should be based on the same image. Let's see, Python 2, like I have these two. I ran this image twice, so I have two instances or two containers based on this image. So I'm gonna go ahead and remove these. And this one. There are also some other commands, like there's a prune command, which I'm not gonna get into right now. But there's, you know, other commands to help you do this kind of simple cleanup. You can also run the container and then tell it, like, after you're done running, delete the instance. So that you pass in --rm. So this will run the container. It will run this container. It will execute bash against the container. And then I get access to it on my shell through this -it flag. And then I do whatever I want. And when I exit the container, it will automatically delete the image. I can do ls blah 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 and then exit. And if I do Docker PS-a, I don't have an instance of that sticking around. Okay, so that's the basic idea. I'll also walk you through real quickly creating an image. So if you want to create your own custom image, so here I am. I'm going to create a Docker file, and there's no extension. You just call it a Docker file. And Docker files, there's a lot of different commands you can do. There's a small subset of keywords, but what you're going to need for every container is from. So you start with from, and then let's say I do Python -2. So you specify the container, just like we did here, where you do Docker pull Python -2. If you want to pull down that image, you basically do the same thing here. So we're going to start with Python 2. Everything else we do is going to assume that we're in Python 2 container. And I'll add a file here. My script.py. And I guess I'll just do print. Hi there. Okay, so my local version of Python doesn't like this, but the container should be fine with it. So from Python, and then what I'm going to do, there are a few things you can do, but I'm just going to copy this over. So copy. And then the syntax for copying is always from to. So copy from, and it's going to assume that I'm in the current directory. So my script .py, and I'm just going to paste it into the base directory of the image. So I can determine, anyway, we're not going to worry about that right now. So we're just going to plop it down at the root of the container. So I start with this image. I'm going to copy my script, and then when I actually run the container, so I don't need to install anything else, but I could do something like run, install pip install all my dependencies or whatever here. I'm not going to do that. CMD is the command that's going to run when I run the container by default. So by default, let's just say I want my script to run. Anytime you run the container, the purpose of running the container is to execute the script. So we'll do that. So Python, this is a little weird, but you have to pass all the each individual word as a separate element in this list. My script. So this is a basic Docker file. We're saying, okay, I want to have a container that has Python 2. So I get this from the official image. And then I want to copy this script I have, this Python file, into the container. And then when you run it, just execute the script. Okay, so this Docker file is a description of my container. Or sorry, it's a description of the image. So this in itself is not anything. This is just a basic blueprint. And actually, in order to actually make a container, sorry, my bad. Okay. In order to create an image, you have to build an image. So there's another Docker command for that. I'm going to zoom in a little bit. Okay, so I have my Python file right here. So I'm going to do Docker build, and then the argument that build wants is just a path to a Docker file. So build just wants a Docker file, and if I'm at the root level and my Docker file is at the root level, I can just pass in dot. If I have the Docker file in some subdirectory somewhere, I pass it the relative path. So that's the basic command. Just like everything else in Docker, you can add other flags, so other customization. So I'm gonna add one customization, and that's gonna be the name. So I want to give this image a reasonable name. So -t, and -t stands for tag or name, and my Python 2 image. Let me go. So I'm saying I want Docker to start with this description and actually build me an image and call it my Python 2 image. So I run this, and Docker is going to execute a bunch of stuff. It might have to download stuff. It's noticed that this line is cached. So since I had already downloaded this image before, so it tries to be as efficient as possible. But anyway, now I have this image. So if I do Docker images, I have, no, that's not it. My Python 2 image right here. So now that I have my image, I can actually run it. And because I've made the default run command something interesting, if I run it, I should actually see the output from that script. So Docker run, and then the image name, which is my Python 2 image. And if I just pass it that, it actually will execute the script there. I can also override that, basically. I can run it and do the usual bash. So just what's happening in the container, maybe troubleshoot something or install something else or whatever. And then I do bash. And now I'm inside and I can see that my script is right there. So I could actually just run the script manually, Python, my script, and it runs there. And when I'm done, I exit, and I can I'm back in my machine, and whatever has happened, my machine should be totally isolated from whatever was happening inside that container. Docker image, let's do Docker PS. Nothing's running. Docker PS -a, and I'm gonna clean up a couple of these. So here's those instances I just ran. So Docker RM, pass it this one, and then pass it this one. And that's pretty much it. So any questions about basic Docker stuff?
So would you basically then, if you created an application, you can put that in the container and then people can just run your whole application like you did with the Docker run your Python, and it just spit out the file, so we can make it so that the whole application would just run instead of but just run in the Docker.
Exactly. So if you have a like a one-off kind of thing, you can do that, and then other people can pull down your image and they can run it. It's even easier than like, okay, here's my GitHub repo, so pull it down and then install all the dependencies and make sure that you're running Python, at least Python 7 on your local machine, and then you can execute it. You just say, here's the image. As long as you have Docker installed on your machine, you just do Docker run my image, and that's it. So it makes it a lot easier to share things. So yeah, you can do that with like one-off images, like this script would be an example of something that just it just runs and then that's it. You can also do the same thing with like servers that run forever, basically. So you could create an API, and instead of running it from localhost like in a development server, you could create a Docker image. You can run it out of the Docker image.
I like it. That's really cool.
Yeah, it is pretty cool, and Docker is everywhere now. So it's not guaranteed that you'll work with it, but it's pretty unlikely that you won't ever work with Docker. And like I said, I'm gonna try and make you guys guinea pigs and use Docker when you actually deploy your applications. So frankly, it's not that much harder than this. It's just it'll be there'll be a few more lines here, but this is really the basic idea. I start with a base image. Maybe I install run pip install -r requirements.txt or whatever I want to install, and then copy over your code, and then usually just run your code. So okay, if there are no questions, then you guys can get started